So I'm going to actually start recording here. Today is, of course, 3/12/19. That's a cross-section of a stream, and you'll notice that there are a bunch of rocks. Duh. There are spaces in between those rocks. And those spaces, now you don't need to know the term interstitial, but those are called interstitial spaces. And there's like a whole other ecosystem in between the rocks, if you can believe that. Who here has gone picking up rocks in a creek? I'm going to assign you homework. If you haven't gone picking up rocks, you should, but you might want to wait till the water's a little bit warmer at this point in the year. It's not going to be pleasant today. Under those rocks, you've got insects, you've got crayfish, you've got small fish, and those things are food for larger species. I mean, heck, this one nice big flat rock down here might even be big enough to have hellbenders under it. We don't know. So what happens, what did the willows prevent? Stream bank, it's an 8th grade erosion. Yeah, stream bank erosion. When the stream banks start to erode, that mud trickles into the river and it starts to fill in these spaces. And once you fill in those spaces, guess what? You don't have room for all those nice little insect species. And those are the things that form the bottom of the food chain and provide food for your fish and your other larger organisms. And once that river, we call it silting in, once it silts in, all those other life forms disappear. So if you've been in a creek that was mud-bottomed, it's not a good sign. That's not a creek that's going to support a lot of sort of high-quality life. You know, the best streams and creeks have got exposed cobbles and boulders and lots of spaces in between the rocks because that's where all those little things live. So, you know, how did they benefit fish? Well, because they prevented the elk from eating the willows, which prevented the stream banks from eroding, which prevented the silt from filling in the spaces that prevents the bugs from living there, which prevents the fish from getting a decent meal. It's complicated. Holy cow. Who would have thought? How did they benefit the beavers?
Build their dams.
They built dams for them. That is so considerate. I didn't know that wolves did that. You know, they're nicer than everybody makes them out to be. So if there are more willows, that's food for the beavers because there were more willows. So they benefited, the wolves benefited willows because there were more willows. Why were there more willows?
Because there was less elk to eat on.
Oh, fewer elk grazing. Aha. How did they benefit grizzly bears?
The carcasses.
Leftovers. Grizzly bears aren't picky. They'll eat leftover wolf carcasses or the carcasses of wolf kills. Same thing for coyotes. They're also good scavengers. They'll eat the leftovers that wolves leave behind. There's plenty of meat on that. The one thing I want to point out when we think about the willows and the wolves, did the wolves have to actually eat the elk to get them to stay away from the willows? Has anybody here ever been tormented by an older sibling or an older cousin or a neighbor kid? Or just, you know, somebody who really just didn't like you? So I had a friend in high school, and I'm not claiming in any way, shape, or form that this was a functional family he was from. His older brother used to chase all the younger siblings around the backyard with, like, baseball bats and shovels. Like I said, not in any way claiming that this is healthy. But he said when he got home from school, the very first thing he would do was check to see if his older brother was home. And man, if his older brother was home, he laid low, he slunk upstairs, he went to his room, he stayed quiet, and he stayed in there. If his older brother wasn't home, he could play in the backyard, he could play in the living room, he could do whatever he wanted. But man, his older brother was there, low visibility is the key to survival. That's kind of the principle the elk are operating on. With no wolves, you can hang out on the stream bank all day long and eat all the willows you want. Woohoo! It's a party! Once there are wolves present, even if it's not about them killing you, there's always the threat they might. So you tend to stay undercover. You tend to not want to stay out in the open too much. Be like my friend, avoid your older brother. Or in the case of elk, avoid the wolf. Change your behavior, change where you're at, so that you're less likely to be eaten. You don't have to kill them all. You just have to scare them. It's a terrible, terrible way to run an ecosystem. Well, you know. Okay, it leads us to this idea that every single thing in an ecosystem is connected, and when we tug on one thing, we tend to find it connected to everything else. The last question, the one we didn't talk about, it's an essay, so I wasn't going to necessarily screenshot the results, but the question was, do you think we can always tell what a keystone species is before we kill them all? And answers varied, and some people said, well, yeah, if we study the ecosystem in depth, probably true. But a few other people said, you know, a lot of times you really don't know until something's gone how tightly woven into something that was. So since you people are patient and kind and you put up with my shenanigans and hijinks, I have shenanigans and hijinks for you. You're also nice about putting up with my shenanigans. So you're all tied together, to put it simply. And if each one of these strings represents an ecological relationship, let me give you my anti-touchy-feely, fuzzy BS thing. I hate like self-help speakers and motivational speakers. Oh. Every time they call a motivational speaker in, I sit in the back grouchy and fact check mentally all their statements and make notes so I can go fact check them later, because I think half of what they have to say is a bunch of made up hooey. But that's just my little data-based nature. So anyway, you know, motivational speakers say things like, it's all about the relationships. And if you're a teacher and you go to teacher workshops, and this is one of the big things now, I mean, it's partly true, I roll my eyes, but it is partly true, like, it's about building relationships. Oh God, I want to vomit. Yes, it makes me cringe. It makes me like, I want to punch something. But, you know, that's just me. But here's the thing. In an ecosystem, so in ecology, in this kind of biology, it actually is all about the relationships. Literally all about the relationships. Quit pulling, you're going to take his head off. We want everybody's head to stay on their shoulders. So, if it's all about the relationships, let's look around. Who here are you connected to? Now, if each of these strings represents an ecological relationship, how many of you are connected to the green string? Okay, so 3 of you, 4 of you. Don't tie your finger off. Okay, don't let it fall. So that's, you know, there are what, 3 or 4 species connected together in one relationship. What about the light blue there? 3, 4 species? What about the dark blue? That's a big web. That's a lot of species. So, you know, if one of you let go of the dark blue, don't do it. Do you think it would be catastrophic to everybody else on the dark blue? Maybe, maybe not. We don't know. But there are a lot of connections there. What about this particular one here? It's just me and Chloe. So what happens if I let go? Does she have other connections?
Yes.
Yeah. If my species goes extinct, she probably won't notice. I mean, she might notice. I don't know. But is it going to sink her?
No.
Probably not. I mean, we don't know. We don't know what any of these relationships actually are. And I'll be honest, I used to do this in a much more complicated and time-consuming manner where I had little labels and, like, I would give you a card that said, you're a white-footed mouse. You're an oak tree. You're a white oak. Oh, my God, it was exhausting and crazy and took way too long. This is, we don't know what species these represent. We don't know what these relationships are. We just know they're relationships. So I could drop out and she might be okay. What happens if Chloe drops all the connections that she has? Well, if she's extinct, who here is affected by that?
Oh,
Everybody. In multiple ways. That starts to sound like a keystone species to me. We don't always know when something is a keystone species. Again, and whoever said if you study the ecosystem closely enough, you should know, is absolutely right. But we don't always understand all the parts of the ecosystem. So I'm going to pause this while we gather up our ecological connections. I want to talk about trees. Look at those trees. There's one little person standing there. Has anybody here ever been lucky enough to go to the Pacific Northwest? Okay. Here are my instructions for you. Somebody ever walks up to you and says, hey, do you want to go to the Pacific Northwest? The only thing you should say is either yes or when do we leave? That's it. I mean, unless they look really crazy and like psychotic, then you shouldn't go with them. But, it's amazing. My best friend lived out there for many years, and I got to spend a lot of time in the forests out there, and they are not like our woods. This is the land of big trees. Even their small trees are big. Their forests are a whole different scale than ours. That's a person. That's a person in there. Look at how tiny she is. These are mega trees, and they talk about out west these mega trees in the whole Gesundheit Cascade Range. So like outside of Portland and Seattle and Oregon and Washington State, Northern California, this is where the redwoods are. And there are other trees that are nearly as big as the sequoias and the redwoods. You ever get a chance to go, you go. Now here's the problem. Do you know what nitrogen is?
Yeah.
What?
It's a gas.
It's a gas. So these big, giant, beautiful trees. Well, I mean, they need nitrogen. You need nitrogen. Nitrogen is a gas. It's 70% of our atmosphere. That's fantastic. So we can get all the nitrogen we need just by breathing, right? Wrong. Sadly, we can't use the nitrogen in the air. Neither can trees. Huh? Well, no, not really. It's not. But you need it. You know why you need it? There's something in every single cell of your body that is made largely of nitrogen that passes on your genetic information. Long, skinny chemical. DNA. All those bases are made of nitrogen. And all the proteins that are built off the instructions coded in your DNA are made of amino acids, which are nitrogen-containing chemicals. So all the proteins that your body's making have nitrogen as a base. It's kind of important. Sounds like I need it. I should get me some. Well, these trees need it too. Here's the problem. These trees can't possibly exist. They figured it out. They did the math. Biologists looked at them and they did the math and they did the chemistry and they did they balanced the equations. And the problem is these trees are so big that there is no possible way that they can fix enough nitrogen to support themselves, so they clearly cannot exist. Blasphemy. They can't possibly exist. It's not possible. These trees can't get enough nitrogen. This is kind of like the bumblebee can't fly. Bingo. These trees can't exist, and yet, voila. So how the heck do they do it? It's kind of a mystery. So your homework tonight is going to be two things. A short video, like under 5 minutes, on the nitrogen cycle, because we should know what nitrogen is and how we get it from a form that is out in the air to something that we can use and trees can use and your dog can use and everything else can use. And a short reading on how these trees defy all expectations and are there. Now, all of you have been able to log into Actively Learn, I believe. Okay. The other class, there are still people having problems, but I will not put the reading on Actively Learn because of that. I'll put it up as PDFs or something. We'll see. There'll be a short quiz though. So, pardon? Tomorrow when you walk in, short quiz over the homework. So it'll be just like last night, short video, short reading, and I will go ahead and put the nitrogen video up right now. I have to scan the PDF in, so you can then get started on that one. That's it.